Have you ever pondered why Mars, our captivating neighbor, is renowned as the red planet? It's a question that has sparked intrigue and curiosity for centuries. Mars's signature crimson hue has inspired countless science fiction stories and fueled our imagination. From afar, it might seem like a simple case of color differentiation among celestial bodies, but dig a little deeper, and you'll find a treasure trove of geological and atmospheric factors at play. Common misconceptions abound, from the planet being covered in rust to it being stained by Martian blood. But what if I told you the answer is not as simple as it seems? To understand why Mars is red, we must first delve into the science behind colors. Colors, as we perceive them, are a fascinating trick of light. The color of an object depends on the light wavelengths it reflects. When sunlight, which is white light, hits an object, certain wavelengths are absorbed and others are reflected. The wavelengths that are reflected back to our eyes determine the color we perceive. So, when you look at a ripe tomato and see red, it's because the tomato's skin is absorbing all colors of light except for red, which it reflects back to you. Now let's introduce a key player in our Mars mystery, iron oxide. Iron oxide is a compound that forms when iron and oxygen react in the presence of water or air moisture. It's more commonly known as rust, and it has a distinct red color. This is because iron oxide absorbs light across most of the visible spectrum, but it reflects back light in the red part of the spectrum, hence we perceive it as red. And here's where the plot thickens. Mars, our celestial neighbor, has an abundance of iron oxide in its soil. In fact, it's so rich in this compound that it has earned the nickname, the red planet. The fine grains of iron oxide, or hematite, give the Martian surface a butterscotch tone and contribute to the reddish hue of the Martian atmosphere. But why is Mars so rich in iron oxide? And how did it get there? Well, scientists believe that the formation of hematite powder on Mars is a result of chemical reactions involving metallic iron or magnetite with water, oxygen, or hydrogen peroxide. Over time, wind erosion after the disappearance of Mars's thick atmosphere, water bodies, and active volcanoes formed the red soil we see today. Now that we've grasped the science of colors, let's apply it to Mars. Mars, a planet millions of miles away, is a world of iron oxide, or as we know it, rust. Now, this might seem odd at first, but let's delve a bit deeper to understand why this is the case. You see, the distinctive red color of Mars, the one that has earned it the epithet, red planet, is due to the presence of a mineral known as hematite in its soil. Hematite is an iron oxide, and it's this iron oxide that imparts the reddish tint to the Martian soil. But the tale of Mars's color doesn't end there. The story gets even more fascinating when we consider the texture and tone of Mars's surface. The Martian soil isn't just red, it's a beautiful blend of hues, a palette of iron-rich colors that range from butterscotch to deep ochre. This variation in color is due to the fine grains of hematite scattered across the planet's surface. These tiny grains, each no bigger than a speck of dust, are what give the Martian soil its butterscotch tone. It's like a cosmic dusting of cinnamon on a planetary scale. But wait, there's more. These fine grains of hematite aren't just lying around on the surface, they are actively contributing to the overall redness of Mars. As sunlight strikes these grains, they absorb certain wavelengths and reflect others. It's the reflected light that we see, and it's this light that makes Mars appear red to our eyes. What's even more intriguing is that these grains aren't evenly distributed. In some areas, the concentration of hematite is so high that the soil appears almost blood red. In others, the concentration is lower, and the soil takes on a softer, more golden hue. This patchwork of colors creates a mesmerizing, ever-changing landscape that is both alien and oddly familiar. So, it's the iron oxide in the soil that paints Mars red, but how did it get there? Well, that's a tale for another time, but for now, let's revel in the beauty of our rusty neighbor, a world of iron oxide, a world painted red. The red soil of Mars didn't just appear out of nowhere. It's the result of years of chemical reactions and erosion. Now let's delve into the science behind this fascinating process. The story of Mars's red soil begins with iron. Iron, or more specifically, a mineral known as magnetite, was abundant on the Martian surface. Over time, through interactions with water, oxygen, and hydrogen peroxide, this magnetite underwent chemical reactions, transforming into a new mineral called hematite. Hematite is an iron oxide mineral, and it's this mineral that gives Mars its distinctive reddish color. But it wasn't enough for the hematite to simply exist. It needed to be in a specific form to create the red soil we see today. Enter wind erosion. Over the millennia, the harsh, relentless Martian winds have been grinding down the surface of the planet. This process has gradually turned the hematite into a fine powder. These tiny grains of hematite are what color the Martian soil. When sunlight hits these grains, They absorb all other colors of light and reflect back red. The result? The butterscotch tone of the Martian surface that we see from our telescopes. However, the red soil tells us more than just the story of Mars's color. It also provides insights into the planet's past. You see, the existence of hematite suggests that there was once water, oxygen, and a thicker atmosphere on Mars. The wind erosion implies the presence of active weather systems. So the red soil is a testament to Mars' past, a time when it had a thick atmosphere, water bodies, and active volcanoes. The red soil of Mars is much more than just a color. It's a window into the planet's history, a history that we are only just beginning to understand. But it's not just the soil, even the Martian atmosphere contributes to its red appearance. You see, the atmosphere of Mars is home to countless tiny particles of dust, many of which are tinted by finely powdered hematite. This iron oxide mineral, which also gives Mars its red soil, is responsible for the reddish hue that we observe when we gaze upon the Martian atmosphere. But how does this work? Well, as sunlight reaches Mars, it interacts with these hematite particles suspended in the atmosphere. This interaction causes the sunlight to scatter in all directions. However, it's not an equal opportunity scatter. The process is biased towards certain colors, particularly those on the red end of the spectrum. This is due to a phenomenon called Rayleigh scattering, named after the British scientist Lord Rayleigh, who first studied it in depth. On Earth, our atmosphere scatters short-wavelength light, such blue and violet light, to the far corners of the sky. But on Mars, the dusty atmosphere prefers to scatter the longer wavelength reddish light, giving the sky its signature color. From a distance, this scattering paints the entire planet in shades of red, making Mars appear as a reddish beacon amidst the sea of stars. And it's not just a superficial appearance. This red scattering of light penetrates deep into the Martian atmosphere, coloring everything with a rosy hue. So the combination of red soil and a reddish atmosphere is what gives Mars its distinctive color. So, the mystery of Mars' red color is finally unraveled. We've journeyed together through the captivating science of colors and discovered the secret behind Mars's unique hue. It's the iron oxide, or hematite, present in the Martian soil that lends the planet its signature red. But that's not all. We've learned how the red soil itself formed over time. Wind erosion after the disappearance of Mars's thick atmosphere, water bodies, and active volcanoes played a crucial role in the creation of this fascinating landscape. And let's not forget the Martian atmosphere that adds a dash of red to the canvas, thanks to the fine hematite grains. It's a spectacular display of nature's artistry, isn't it? From a curious question to a scientific expedition, we've truly embarked on an incredible journey today. And there's so much more to explore in the vast expanse of our universe. Remember to like and subscribe, and let us know your thoughts on this fascinating topic in the comments below.